Welcome everyone. We're going to solve Leetcode problem 202, happy number, where we're asked to determine if a number is happy. And a happy number is a number whose sum of squares eventually equals the number 1, and it's not a happy number if it just loops endlessly. So reading through the description, we can kind of figure out an overall process. So first, we need to start with n, and we need to break it into its digits. Then from its digits, we need to calculate the sum of squares. Let's just say SOS. And then with its SOS, we need to check if there's a cycle or if it's equal to 1. And that's essentially it. But let's take a look at some of the examples so we can figure out how this would actually work. So if we look at the input they give us, which is n is equal to 19, the first step is to break 19 into its digits, which is 1 and 9, and then calculate the sum of squares. So 1 squared plus 9 squared, which is equal to 82. And then we continue that pattern. So we do 8 squared plus 2 squared, which is equal to 68. 6 squared plus 8 squared, which is equal to 100. And eventually we get 1 squared plus 0 squared plus 0 squared, which is equal to 1. So this is a happy number. Now let's take a look at another example where n is equal to 2, and this one we know is not happy. So what we do is we start with n is equal to 2. I'll make a little column here. All right. So we do 2 squared, which is equal to 4. And then the next line would be 4 squared is equal to 16. And then we do 1 squared plus 6 squared to 1 plus 36 is equal to 37. We have 3 squared plus 7 squared equal to 9 plus 49 is equal to 58. And then that's 5 squared plus 8 squared, 25 plus 64 is equal to 89. Now this keeps going, but just bear with me. We're just going to work it all the way out. 89, 8 squared plus 9 squared equal to 64 plus 81 is equal to 145. We have 1 squared plus 4 squared plus 5 squared equal to 1 plus 16 plus 25 is equal to 42. We have 42, that's 4 squared plus 2 squared is equal to 16 plus 4 is equal to 20. Then we have 2 squared plus 0 squared, which is equal to 4. And right now we're just going to stop for a second. So if we look at all the values we've seen, we got 2, 4, 16, 37, 58, 89, 145, 42, 20, and 4. And if you notice, we've now seen 4 twice. So this is what they mean. This is what they mean by a cycle in the description. So as we calculate each sum of square, if we eventually see a number that we've seen before, that's the cycle. So making our way up to the top, the process or the intuition is you start with n, break n into its digits. From its digits, calculate the sum of squares. And then for each sum of square, we just need to check if we've seen it before. If we've seen it before, it's a cycle. And if it's equal to 1, then it's a happy number. And that's how you solve it. So for a Python solution, you can see here, we could first create a set that we'll use to check for any cycles. We start with n. So while n has not been seen, which means it's not in a cycle, and n does not equal to 1, we loop through. So that's the iterative step. We add n to our set of seen numbers. We break n into its digits. So here's a short notation to do that. And then for each digit, we sum total the digit squared, which is the sum of squares. And then we set n equal to the total. And so now this is going to repeat while n is either not been seen or until n is equal to 1. And when n is equal to 1, it returns true for happy. And when n is not equal to 1, it returns false for not happy. And that's the solution for happy number.